Hello, this is Vami from InvenSense. This training material was developed to aid people bringing up the MOD1600 on Arduino Zero and the Pixoc autopilot platforms. I'm going to now talk about downloading the release package from InvenSense Developer Corner. Go to the download section. You would need to create a user login to get into the developers corner, and the way you download the driver is by going to here, accept the terms and condition, and the download should happen in any second. Once the firmware is downloaded, go ahead and unzip the downloaded release package. In here you would find the datasheet, library for the Arduino Zero development platform, and the porting guide to the Pixoc for MOD1600. I'm going to now talk about the evaluation platform for the MOD1600. For us, we are using Arduino Zero board as an evaluation platform. The image just above the Arduino Zero is a carrier board, or the shield as we call it, InvenSense shield board. This board mates to the top connector of the Arduino Zero, providing us the 7-pin MOD-X connector that connects to a MOD1600 through a cable. When you order for the MOD1600 evaluation platform, what instance you would get is these three boards and a connector that connects from MOD1600 to here. And for documentation for this evaluation platform is we have the preliminary data sheet, the sheet that talks about the specs, the hardware dimensions, and anything and everything that's related to the MOD1600 module. Apart from that, we also have a software documentation PDF. Let me just walk through the release package, pointing out the location of various this is where the documentation exists, and this is the Arduino Zero library. This is a library that you import into the Arduino Studio for you to have a library for the MOD1600. I'm going to unzip this file to show all the contents of this zip file. Okay, so these are the contents of the zip directory. The software, the EMD software guide is right here, and it delves into the APIs that are supported for the document, and also it talks about how to set up Arduino Studio for the development. And we also have a doxygen of the entire library. All you need to go to the index HTML page, and from there you should be able to see the documentation generated by doxygen for the source. I double clicked on it, it might take a couple of seconds. Okay, so we went through the documentation for the library and the documentation for how to use the Arduino board. And now we have some example sketches for bringing up the MOD1600 easily, and this is where the source for the entire driver exists. Okay, let me go ahead and open up the Arduino Studio. Now I'm going to talk about the Arduino IDE. IDE is a development environment for evaluating our MOD1600 board using the Arduino Zero platform. The document goes into the detail. I'm going to just cover through a subset of the configuration that you need to do. One of the things that you need to do is install the board drivers for the Arduino Zero device. Another thing that you need to do is to set the programming port. Also, we are using the programming port of the Arduino Zero board for programming, and Arduino Zero is based on an Atmel, so we are using Atmel debug port for programming and debug. These are the example sketches that are provided along with the release package. So let's open up the temperature stabilization sketch. You build the sketch using this arrow mark right here. It takes up to a minute to do the build and program for the first time. Later on it might be a little shorter by a quarter, but it does take up to a minute to do both build and verify and upload the sketch onto the hardware. Once the build is completed and verified, this program takes 51% of the maximum memory available. So we just compile and verify the code. Now we're going to go ahead and upload the code. Yeah, once it's uploaded, we have something called a serial monitor. The same programming port establishes a debug console for us to see the data that's being transmitted by the chip. So it looks like the programming got completed and the program started. So let's go ahead and open the serial monitor port. Okay, here it is. So this is the programming port and the debug port. What you see here is it received 499 events of the temperature data over 5 seconds. So the data is streaming out at close to 1 kilohertz. So in an ideal world we would have got 5,000 out of there, and the average temperature was 64.897 over those 5,000 samples. The low temperature was 23 and the maximum temperature was 25. You see 23 here because the device started off at room temperature and ramped up to 65 degrees in about 5 seconds, and from there on you would see that it captured almost 5,000 events in 5 seconds. The average was 984 degrees, the low was 64.8 and the maximum of 65. And it also received 5131 events of the accelerometer in the same files. So let's quickly walk through the sketch to get an idea of what to expect for the example code. So these are all standard definition for serial port, timestamp, and so on. The MOD1600 doesn't use DMP3 image, it just uses the DMP4 image. You would see that here, and also it needs a M0 image that runs in the M0 SoC processor. These are a couple of debug messages, print messages, function that implements millisecond. So this is the main callback function. As part of initialization, this callback function gets invoked every time a new data is available. In our case, we have requested sensor type temperature, uncalibrated gyro, and TSIMU is the feature that enables and maintains the temperature of the MOD1600 at 65 degrees as we have seen on the serial monitor. So easy device initialization is one that actually initializes the chip and configures it to the known configuration that we want. So we have a function for resetting it. This is a general utility function that handles the temperature stats, gyro stats. Okay, I think that's it. The API that you use for starting the sensor is INV Easy Device Start Sensor. We should have a stop sensor to stop it. This is the poll function that actually polls for the data ready and reads the data out of the sensor. As I mentioned earlier, Easy Device Stop Sensor is the API that you need to use to stop the sensor. Okay, I think that is it for the Arduino Zero or development platform IDE description, and that's it. I've created a very good shell script that automatically downloads the open source PX4 autopilot software and applies the patch to the driver so that it builds on Autocopter. So what I'll do is I'll go ahead and kick off that shell script so that while it's downloading and installing the patch, I'll go ahead and speak to you guys in detail about what the patch does. To start with, let me go ahead and get a couple of terminal windows up. So terminal here. So I'm using Minicop to establish a communication port with the debug port on the PIXOC. For this project, we are using the PIXOC module as an hardware platform. A picture of PIXOC is there up here. Let me show it to you. This is a PIXOC autopilot, and we install the MOD1600 towards the top of the autopilot unit with the connector pointing the same way as the USB port connection that goes up here. And apart from the MOD1600, we also had a serial debug port connected to the PIXOC to establish the debug port. I'm going to now go ahead and instantiate the handle to the debug port. And as you see, I display the average values of the accelerometer, gyroscope, and the temperature up here on the debug port. I'm going to create another open up another terminal window here. What I would do here is I would go ahead and execute the script that's going to download the drone code autopilot source, and it's going to port the MPU drivers onto the port and creates a new build for us. Okay, let me get to the download section. CD mod. We need to go to this driver, and this is the same driver that we downloaded it from the InvenSense developer corner website in the earlier video. Okay, we have a shell script right here. This is what we want to run to create drone source built of the MOD1600 ported onto PIXOC autopilot. So let me go ahead and okay. So while the script is downloading the open source autopilot and installing the port, I'm going to talk through what the shell script is doing. Okay. So with the first instruction is I'm creating a MOD1600 directory at the same location where we execute the script. First you get into the directory, and then what I'm doing is I'm cloning the DIY drones autopilot Git repository onto the local server, and then I'm checking out this branch, the Copter 331 branch, so that our driver can be ported to this particular branch. The way the build works is the Autopilot has 3 submodules in there, and when you check out the code from the open source repository, these 3 submodules don't exist in source. And the build process, as part of build, when it realizes that these 3 submodules don't exist, it goes ahead and fetches it. So the first time around when it built it, it realized that it was missing the submodule. So we would go ahead and remake the source code. So this time all the submodules would have been downloaded and be ready for us to build it. So when you run it, most likely when you go past this, we want to make sure that we have a very stable build. So for that reason, we would go ahead and clean our build and rebuild the PX4 for version V2. V2 stands for the hardware version of the Pixhawk Autopilot. Once we have the stock Pixhawk Autopilot build ready for the branch Copter 331, we would go ahead and apply the patch. So we have 2 patches. One patch is for the Autopilot. Autopilot is the overarching project for the Autocopter as an autopilot, and we also have a patch for the PX4 firmware. PX4 is more hardware specific. The Pixhawk is based on the PX4 architecture, so all the drivers for the MOD1600, 95% of the code gets applied to the PX4 firmware, because this is where all the drivers stay, and this is where all the hooks to expose all the data pulled from the sensors are there. And then we once all the code is ported, we would go ahead and redo a fresh build. So here, in a sense, what you guys have is one script that downloads the open source Autopilot project. It checks out the branch on which the port works, and then applies the driver as a patch to the project and does a clean build. Thanks for watching the video, and feel free to post comments and explore the Developers Corner section on InvenSense website, where you'll be able to find FAQs and other resources for porting and integrating MOD1600 onto your target platforms. Thank you.